Hello everyone, my name is Diksha and I am from the Bodhi Academy. Today I'll be going to teach amines chapter from 12th standard chemistry. Okay, so let us start with the amines. So this is one of the important chapter in terms of organic chemistry from 12th standard, and it is similar to the rest organic chapter, that is haloalkanes, haloarenes and alcohol phenols along with aldehydes. Okay, so let us start. Now in amines we are going to study the compound which comes under amines. So amines are basically derivatives of ammonia. Okay, now we know that ammonia, what is the formula of ammonia? It is NH3. Okay, now what are called as derivatives of ammonia? When we replace, now NH3 structure will have 3 hydrogen, right? So when we replace any of the hydrogens from this, the hydrogens which are attached to the nitrogen, it will be called as derivative of ammonia. So in first case, if you replace one hydrogen, it will be and replace it by R group. Okay, so the formula will become RNH2. In second case, we are replacing two hydrogens with two R groups, so it will become R2NH. And in third case, we are replacing all the hydrogens with R, that is R3N. So in first case, when we replace one hydrogen, it is called as a primary amine. When you replace two hydrogen, it is called as the secondary amine. And when we replace all three hydrogens, it is called as a tertiary amine. So these are the three types of amines based on their replacement of hydrogens. Okay, so I will show you the examples of primary, secondary and tertiary amine. So if I have this particular amine, okay, we will take some alkyl group in place of R, that is CH3, CH2, NH2. So here we can see that there are two hydrogens and at one side N is attached to the R group. Okay, so this whole is the R group. So this will be called as primary amine. Okay, one simple way to remember primary, secondary, tertiary is you have to look at the number of hydrogens. So here whenever you have two hydrogens, it is primary amine. Whenever you have one hydrogen, it is secondary, and whenever you have no hydrogen, just nitrogen, you have, it is tertiary amine. Okay, so let us try to see what type of amines we have here. In first case, in first it is primary amine since we have H2. In second case also it is H2, so it is primary amine. In third case we have just NH. We are not having H2 here, NH. NH means secondary amine. In fourth case we have just nitrogen, and to that we have R group attached. So this is tertiary amine. Okay. So let us begin with the nomenclature. Okay, so there is a simple way like other how we name other organic compounds. Here also there is a simple way to name the compound. So let us start. Nomenclature, the general name to general name or the common way to name this compound, the general name is alkanamines. Okay, so basically here this name is given for primary amines, that is alkanamines. Alkanamine means whatever alkyl group is attached, it will come here and it will end with the amine. So based on that we will name the first compound, that is having two carbons in alkyl group. So two carbons means which group? Ethyl group or ethane group, and attached to that we have NH2. So the name of this will be ethanamine. Okay, since we have two carbons. In second case we have how many carbons? 1, 2, 3. So in this case it will be propanamine. Okay, propanamine. Then in third case, now here there is a slight different way to name this since it is a secondary carbon having only one hydrogen. So here we have to see two different things. First of all, there will be only one main chain here. Okay, so other R group will be substituted here, because since here we have just hydrogen attached to nitrogen, there are two R groups here. So we have to see which R group will be having considered in the main chain. So there are two R groups, CH3 and CH2 CH3. So the group which is having more number of carbon is considered as the main chain. So here we can see this group having 2 carbons, or alkyl group having 2 carbons is the more number of carbons. So this is our main chain, and this will become now substituent. Okay. And in our previous chapters, we used to give the substituent numbers, but here we have to not give the numbers, but we have to write n instead of it. Okay, since we have this n. So here how we will write the name? CH3 is a substituent which is a methyl group. It is attached to the n. So we have to write n methyl. Okay, because the substituent is methyl, n methyl, and then you have to continue with the name, that is ethane. No, so n methyl ethanamine. Okay, so n methyl ethanamine. Now when you have one n, it will be secondary name. Okay, now here this is tertiary. So we have 3 different R group. You can have 3 different R group, 3 same R groups, 2 same and 1 different, 1 same, 2 different. Doesn't matter. Okay, so here, and same thing we have to follow here. We have to see which alkyl group is having more carbons. So this alkyl group is having more number of carbons, and these 2 groups are having only 1 carbon. So these 2 groups will be substituent, and this will be our main chain. So here, since there are 2 substituent, our name will be n comma n dash dimethyl ethanamine. Okay, now if I have a different group over here, that is if I have suppose ethyl group over here, C2H5, okay, and we have to write the name, then we have to, now if I am taking ethyl group here, then these two, both the groups will be, you can choose any group from this to be a main in the main chain. So you can choose any one of this as a substituent, and other will be our main chain. So if I take this as a substituent along with this, now how you have to write the name? You have to see the alphabetical order first. So E comes first, so you have to write N ethyl, then M comes, so N ethyl, N methyl, and then ethanamine, because ethane is our main chain. Okay, so N ethyl, N methyl, dimethyl. If you have same group, then you have to have N comma N dimethyls. Like it is the same like we used to write in our previous chapters, organic. Okay, now here this is different. Here we have 2 NH2 group along with 6 carbon groups, that is CH2, CH2. So these 6 CH2 groups will form what? It will form, it is in a straight chain, so it will form N-hexane. So the name of this will be, here we have 2 amines. So the name will start with this hexane. At first position, at first carbon we have amine, at last carbon we have amine. So it will be hexane 1,6 diamine. Okay, hexane 1,6 diamine. Then aromatic groups. So benzene ring attached to NH2, the name is benzenamine, and the benzenamine, and the common name that we use for benzene ring attached to the benzene ring with NH2 is aniline. Okay, so we mostly consider this name only, that is aniline. If I have methyl group attached to the amine, it will be, this will have 1 number, so this will get 2 numbers. So it will be 2 methyl aniline. If I have bromine group attached, so it will be 4 bromo aniline. Okay. Then in this case, what we have? We have N. Just N, when you have just N, what does it mean? It means that it is a tertiary type of amine. So benzene ring with N and CH3 twice, that means there are 2 CH3 groups which are attached. So we can write this in another way also, that is we can write 1 CH3 here and 1 CH3 here. Okay, so now our main group will be the benzene. Okay, so here the name will be N comma N dimethyl, N comma N dimethyl benzenamine. Okay, so this is the name of the last one. Okay, so similarly you have to write the names of the compounds which are accordingly like primary, secondary, tertiary based on the how many hydrogen and nitrogen present in them. Okay, now let us move on to the preparation of amines. So the very first method is reduction of nitro compounds. We all are familiar with nitro compounds as we have studied in our previous organic chapters. Benzene, here we are basically looking for the aromatic nitro compound. So this is what, this is a nitrobenzene. Now we are carrying out a reduction of nitrobenzene to give the benzene with amine, okay, or benzenamine. So here reduction of nitro means what, whatever nitro group you have, the reduction of that group will take place. That is, reduction means either removal of oxygen or addition of hydrogen. So here we are carrying out the reduction in place in presence of palladium, which is a catalyst, and we are adding hydrogen, and in presence of ethanol. So we will have product as benzene ring with NH2. So this O2 is replaced by H2, and that's how we get the amine, okay, benzenamine. Similarly, we can carry out the same reaction, but the reagents will be tin plus HCl or Fe plus HCl will give us same group, that is aniline. Okay, so this is basically a reduction in which we produce aniline from the nitrobenzene. Next method is ammonolysis of alkyl halides. Ammonolysis means what? Breakdown of ammonia. Okay, so RNH2, that is a primary amine. Okay, primary amine. When we add alkyl halide, we get the secondary amine. Then we get the tertiary amine. Okay, and then we get the quaternary salt. So first we will see how we get the primary amine. So we can take ammonia plus alkyl halide. Then what do we get? We get the salt. Okay, RNH3X. Then when we react this salt with a base, that is NaOH, sodium hydroxide, what will happen? We will get the primary amine, RNH2. That means one of these hydrogen combines with halogen. One of these hydrogen combines with halogen, and the hydrogen combines with the OH group to form the water molecule, and this sodium combines with halogen to give the sodium salt. So we get primary amine. Then that primary amine, when you again react with RX, that is the alkyl halide, you get the secondary amine. So we will just take one example over here. If I take NH3 plus CH3Cl, then I will get, as this salt, I will not consider this, so I will take directly the primary one. So in presence of NaOH, I will get CH3NH2. Okay, then again if I add CH3Cl, that is alkyl halide, I will get CH3NCH3, and here H, that is a secondary amine. Again if I add CH3Cl, I will get CH3NCH3CH3, that is a tertiary amine. Okay, so I will get these particular groups when I add and keep on adding the same alkyl halide to that. So this is a simple reaction of homolysis of alkyl halides. Next reaction is reduction of nitriles. We all know what nitrile looks like, or how the nitrile, for what the formula of nitrile. So it is basically RCN. When we add, or when we do the reduction of nitrile, like how we did of this nitro group, so here we add hydrogen, or hydrogenation we carry out in presence of nickel, sodium amalgam and ethanol, we will get RCH2NH2, which is the amine, which is a primary amine from the particular nitrile. So if I take example of CH3CN, in presence of this particular catalyst and reagents, we will get CH3CH2NH2. Okay, so this is the example of this reaction. Then reduction of amides. Okay, same way we can reduce amides, but here what we have to do, we have to remove this NH2 along with the oxygen group. So we will have RCH2NH2 as our main product. Okay, RCH2NH2. And here we are using the most efficient reducing agent, that is lithium aluminum hydride and water. Okay, so this is the reaction. Then next reaction, okay, let us take one example in this reduction of amides. Same way we can take CH3, C double bond O, NH2. Okay, that is ethanamide, and add to it reducing agent along with water, and we can have CH3, CH2, NH2. Okay, so this is the example. Next is Gabriel thalamide synthesis. So here we are using thalamide to carry out the reaction. So this is a thalamide. When we react it with base, we get potassium salt of the thalamide. Okay, meaning here H is replaced by K. Okay, when we further react it with the alkyl halide, we get here the K group, or the K potassium is replaced by R group, and after reacting with sodium hydroxide, aqueous sodium hydroxide, we get our main product as primary amine, that is this R. Okay, this R will combine with hydrogens, and we will get RNH2, and the remaining groups remain as the same. That is, if you take here 2 NaOH, then ONA 2 ONA will be 2 ONA will be attached here to this carbon, and this N and this R, they will combine with the 2 hydrogens from this to form RNH2, that is a primary amine. Okay, so similarly you can take any example and write the reaction. And last reaction for the preparation of amines is Hofmann bromamide degradation reaction, in which we first take amide, add to it Br and NaOH. So what we will get? We will get R NH2. Actually, we will expect that we will get RCNH2, but no. In this reaction, there is always one less carbon than we are taking. So here in the reagent side or reactant side, we have taken this carbon, and here one R group. So in minimum 2 carbons, so here we will get one less carbon, that is 1. Okay, so here we will get RNH2 plus Na2CO3 plus Na Br. Okay, that means this is our main product. So if I take example, that is CH3, C double bond O, NH2 plus Br plus NaOH, then I will get CH3NH2. Okay, so this carbon or this carbonyl group is combined with sodium to give sodium carbonate. So that's why we will get the if we take ethanamide, we will get methanamine. If you take propanamide, you will get ethanamine. So this way we will get the product. Okay, so these are the side products, and with this we finish the preparation methods of amines. Okay, so nomenclature as well as preparation methods are of equally important in this chapter, and we are going to study more in our next video, that is the basic character of amines and chemical reactions of amines, and other physical properties. Okay, and about other compounds also. So yeah, so with this we finish our preparation method. So next part we will see in the next video. Thank you.